Hello friends, welcome back to Automation Digest. From today, we will be talking about design pattern. To start with, we will talk about Gang of Four design patterns. Gang of Four design pattern is a collection of 23 patterns from the book Design Patterns, Elements of Reusable Object-Oriented Software. This book was published in the year 1994, authored by four people, Erich Gamma, Richard Helm, Ralph Johnson, John Vlisidis. This was the reason why it got the nickname of Gang of Four. Gang of Four or GOF design patterns is divided into three categories: creational, structural, and behavioral. We will start with the creational design pattern. The creational design pattern deals with creation of object. It consists of five different design patterns, namely singleton, factory, abstract factory, builder, and prototype. Today we would be concentrating on singleton. The singleton design pattern restricts the initialization of a class to ensure that there is only one instance object of the class at any given point of time during the execution of the program. Real-time example of singleton design pattern can be thought of as a president's office or a prime minister's office. There can be only one prime minister or president at any given point of time. Some most commonly used experiences would be a printer. The instance of the printer is only created once for n number of employees, which requires a singleton to perform that activity. A database connection, a logging service by any of the program. From testing point of view, a WebDriver, which can be instantiated only once. With that said, let's get into our IntelliJ and work through the programming of singleton. So I have already created the public class called Singleton Design Pattern, which has the PSVM, public static void main. We will be invoking our Singleton pattern or class from this place. Let's create a class where we would be defining the Singleton Design Pattern. Now, as we discussed, the singleton design pattern restricts us from creating multiple objects of the class. So to understand the design pattern, first let us understand how an object is created. Whenever we instantiate any class, we write new followed by the name of the class and a parenthesis. We may pass on some parameters in the parenthesis. That calls the constructor, either a default constructor or the parameterized constructor based on what we are passing. So to restrict multiple creation of object, we have to make sure that the constructor is not visible to anyone. And then we have to create an object in the class itself. And that object has to be passed along from outside the class. When we want to access anything without creating any object, we require a static method. So the method which should be visible to public, which will be returning the object of the class following the singleton design pattern, should be of static type. Now, there are multiple ways of doing this. We will start with the first one, which is eager initialization. The first step that we would be doing under eager initialization is creating a private constructor so that it is not accessible by anyone outside the class. Once we have done this, we have to create an object inside the class. In case of eager initialization, we declare a variable to be final and define the object in the same line, and we make it private. Once we have done this, we need a method which can be accessed by outside classes. That's it. The singleton using eager initialization is done. Let's check this out. First of all, if I try to instantiate the class, let's see what happens. We are not able to create it. We are getting a compile time error because that is private. Now, the only way we can access the object is by calling the method. That's it. Now the object of the class is created. To verify if this is created only once, we can have the hash code and see if it returns the same value. If I execute this code, the hash code is exactly the same, which is 173.2398722. All right. Now, in place of this, if I make it public and in place of calling it from the method, let's create the instance. These are two different objects which is getting created because now the constructor is no more private and anyone from outside is able to create the object. This is all about eager initialization. Now the next way of creating a singleton design pattern is static block initialization. which is similar to eager initialization, except for the fact that instead of creating the singleton object directly while declaring the reference variable, we would be doing it inside a static block. So the benefit of static block initialization is we would be able to handle exceptions. That's it. If I execute the code, we are able to see the same output because no other instance is getting created. That's all about static block initialization. The next way of creating the singleton object is lazy initialization. In this type of initialization, instead of having a static block, we are checking if the instance was created earlier, else we will be creating it, and all this check is performed inside the same method where we are returning the instance, which is get instance method. So I'll be removing this, and inside this method we would be mentioning if is null, create one. And because we are not initializing the variable during declaration or in the static block, we have to remove the final keyword. This is about lazy initialization. Now this works fine in a single threaded system. When it comes to multi-threaded system, we will have problem. But before that, let's execute the code and check the result. We have exactly same hash code for both the instances. So for a multi-threaded scenario, we would be required to do a thread safe singleton initialization. The first thing that we would require to add here is synchronization. We can add the keyword synchronization to the method, which will make it thread safe. And because the method is thread safe, so only one thread at any given point can enter the method, can go to line number 23, which is checking if the instance is null, and hence either create a new instance or pass on the instance which was created earlier. This works fine, but it reduces the performance because of synchronized associated with the method. Initialization block, on the other hand, gives us better control, hence improving the performance. So we are checking for the instance to be null twice. For the first one, if it is null, we are going and checking if it is synchronized, and then we are creating the object if it is null again. If I execute this code, this works fine. Now, prior to Java 5, there were a lot of issues with the memory. So there was another implementation which is called build-pow implementation, where we had the inner static class called, let's say, singleton helper, which would create the object and send it to our singleton class, which eventually would return the object using a method. Post Java 5, those issues are not in place. So we do not require to use that. Now the next question which arises, is singleton safe completely? The answer is no. We can break singleton. One of the way of breaking it is using reflection. So while we were creating this object from the singleton class and accessing it using the method called getInstance, we can set the accessibility of the constructor as public and create an object that is the power of reflection. So how do we do it? First, we get all the constructors present in the class. Once we have the constructor array, we can iterate through the array and set the accessibility as true and create an instance. Iterating through the constructor array, setting the accessibility as true and creating the constructor. Once we have done that, we can come out of the loop. Now let's see the hash code for this. If you observe, the instance 3 has a different hash code, which means we have created a new object. This is done using reflection. We can safeguard singleton from reflection as well. We will learn about those concepts in the upcoming session. Till then, stay safe. Happy coding.